In lesson 7.4, we're going to talk about tessellations with regular polygons. Now remember, a polygon just means many-sided figure. And some regular polygons, regular meaning that they have all equal side lengths, will tessellate and others will not. For shapes to fill a space, the angles around a certain point must add up to 360 degrees. And the only regular polygons that can create what they call monohedral or one-shape tessellations are triangles. And you'll see that the triangles that we're talking about are the ones right here. The second group that can do this are the squares. And so the squares that we're talking about are the ones down here. And the last ones that can do this are the hexagons, and you can see those down below. So only three shapes can create monohedral, or in other words, one-shape tessellations. Now the reason that is that because if I look at the triangles, for example, that means that each of these degree measurements is 60 degrees. And so if I take and I go, oh, one angle is 60 degrees, and I have 6 of those, then I get a total of 360. Likewise, down below with the squares, I know that each one of these squares has 90-degree angles, and if I have one angle being 90 degrees, then in the end when I multiply 4 times 90, I see a grand total of 360 again. And lastly, if I'm looking at a hexagon, I know that one of these angles is 120 degrees. So if one is 120, then 3 times 120 is 360. Again, all the way around this one point right here, I have to have 360 degrees in order to tessellate the plane. Up to the right, you see that we talk about a pentagon, and pentagons don't work because if I look inside the pentagon, what I see is an angle measurement that's 108 degrees. So one angle at 108, if I look at that and I try to figure out what's going on, I can try 3 of those around there, and 3 of those angles doesn't produce 360, and 4 of those angles would not produce 360, so I'm out of luck. 3 times 108 would be 324 degrees, so that doesn't work, and that's too small. 4 times 108 would be 432 degrees, and that's too big. So the only 3 figures that work are regular triangles, regular quadrilaterals, which we call a square, and then regular hexagons. Again, this is to create something called a monohedral, or in other words, only one shape, meaning only a triangle, or only a square, or only a hexagon. Sometimes we can have more than one shape tessellating the plane if those 2 shapes fit together in such a way where you have each of those producing angles that add to 360. So here what I notice is I have shapes up above. I have an octagon, and down inside I have a square. And what I notice is that the octagon and the square, if I put them in combination, work as long as at any one point that I'm talking about, like for example this point that I just put here, I see that I have 2 octagons and 1 square at that point. In fact, I can look at any point. I'll pick another point off to the right a little bit. Here we go again. And at this point, again, I see that I have 2 octagons touching there and 1 square. Now, when we talk about tessellations, what they talk about here is that if they're going to represent how you say that you have 1 square and 2 octagons, they write it down below as 4.8 squared. The 4 means a 4-sided figure, and the 8 means an 8-sided figure. The squaring means that there are 2 8-sided figures. So highlighted there means that you have 1 4-sided figure and 2 8-sided figures. not on this picture and not maybe even a possibility. If I wanted to say, for example, that I had one triangle, I'm going to use a different color, sorry. Let's say that I wanted to say that I had one triangle, 3 squares, and 2 hexagons. I would write it in the following way. One triangle is a 3. Squares are a 4, but I want 3 of them. And hexagons are a 6-sided figure, and I only wanted 2 of those. So described here in the green highlight is how I'd represent one triangle, 3 squares, and 2 hexagons tessellating a plane.